All right, I think we're going to get started with the first talk of the afternoon session. So our first talk is going to be Qinge Xie, and she's going to talk about using AI models to evaluate privacy policies.
So, hello, I'm Qinge from JetPack, and today I will present our work on evaluating privacy policies under modern privacy laws at scale. And this is a work with another Ph.D. student, Karthik, in your lab, and my advisor, Frankly. So, as a component of the modern privacy laws, many online services are now required to disclose their privacy practice through privacy documents. And for example, this screenshot shows the privacy policy structure from example website. And basically, they provide information about how they collect and share user data, and also some related privacy rights explanation. So we know that most of the privacy behaviors of online services are not externally observable because, for example, those businesses, they can share user data offline, so we cannot really observe those behaviors. And the privacy policy offers a real window into privacy behaviors of those online services, so we can use it to analyze online privacy. And we start this work, our motivation, because after GDPR's enactment, which was in 2018, there is a growing number of privacy laws, including those increasingly adoption of different US state-level privacy laws. After the California CCPA, which was enacted 2020, and in 2023, there are 4 more state-level privacy laws that become effective, such as in Virginia. And in 2024, there is 4 more different state privacy laws that become effective, such as in Florida, and in Montana. So under all those different laws, they have different requirements for the privacy policy a business should provide. And we wonder, what do modern privacy policy contain under all those different privacy laws? So we want to study the visibility from privacy policy, but it's also challenging because privacy policy is lengthy, complex, and does not have a fixed format. And those existing approaches are constrained in privacy practice they evaluate. For example, some of them rely on some rule-based method, and some of them relies on supervised classifier. And the most important, many of those prior work predate the privacy laws now enacted that drastically shape disclosures. And those prior work also did not apply method for large-scale measurement. So in our work, we basically want to perform a systematic, comprehensive, and at-scale evaluation of modern websites' privacy policies. And we want to characterize what privacy policy practice are disclosed and accessing in-depth privacy behaviors. So to perform such a study, first we need to study those privacy regulations. So to ground our evaluation, our team first investigated 10 privacy laws, including GDPR and the 9 US state laws discussed before, and they all require business to provide privacy policies. For example, from this Virginia Consumer Data Protection Act, they required controllers to provide consumers with a reasonably accessible, clear, and meaningful privacy notice, and should include a list of content. So in total, we identified 34 distinct clauses on privacy practice, and we grouped these clauses into 4 themes. So I'll briefly introduce them one by one. The first category is the personal information practice, such as the category of personal information they collect, and for example, the purpose for collecting personal information. And the second category is the explanation of consumer rights, such as many privacy laws grant consumers the right to know what data they collect and the right to opt out their sales or share of user information. And the next is the method for exercising consumer rights, such as a privacy policy should provide the description on the method to submit a consumer request, and also they need to provide contact information. And the last one is some required disclosure of specific information, For example, Florida and Texas, they have some specific requirements about privacy policy should provide a notice of sale of sensitive personal information or biometric personal information. And this is just shows some legal text from those regulations. For example, for the P1, basically from Oregon privacy laws, they mention that business controller should list the category of personal data, and including the category of sensitive data. And the fourth example is one special one from CCPA. So this is the CCPA only because CCPA requires a business that collects over 10 million consumer data in one calendar year should provide the metrics about the number of requests from the consumer they received in the last calendar year about the user privacy request, such as how many requests they received to opt out their service, so stuff. So this is an example of the required disclosure of specific information. So after we grouped those different clouds into 4 themes and guided by this systemization, we then choose to use large language model for our pipeline because large language models have demonstrated significant performance across various tasks, including legal reasoning. And basically, we design those tasks for all identified clauses to characterize the disclosed privacy practice and assess in-depth privacy behaviors. So to be more specific, we design and evaluate the performance of 2 types of LLM tasks. The first one is a coverage task. It's basically a binary task. Is assess whether a privacy policy segment covers the required content of a specific clause. And the second is the inspection task. It's basically a multi-class classification. It's basically the assessment of personal information practice in privacy policy. And we inspect the following information. First, the category of personal information the business collects and shares, and the purpose for their collection and share behavior, and to which third-party recipient they send or share data to. And for both 2 tasks, we also ask LLM to extract the relevant text for the privacy policy, so we can further do some case studies. And basically for the first one is about what privacy policies are disclosed, and the second one is some in-depth privacy behaviors analysis. And we choose to use Llama 3.1 model as our foundation model. We choose it because first it's open source, so other people can directly use our pipeline. And another reason is because privacy policy are lengthy, so it often contains lots of tokens. So using an open source model, we can run the experiment on our own infrastructure. And the next consideration is the policy segmentation. So we know that the current large language model, they actually support very long input contexts, sometimes over 100K. But prior research has shown that longer input can lead to performance drops. So we do segmentation of those privacy policy document and set a 1K token limit. And we also use Markdown format because Markdown format can help maintain the structure of the HTML file. Then to evaluate our LLM task, we need to consider some ground truth data set. So there are 3 data sets we consider to use. The first one is OPP115. So this is actually the most widely used privacy policy dataset in academia. And this dataset contains annotations for 115 privacy policies. But this dataset is created before GDPR and CCPA. And the second one is PPGDPR, which is GDPR specific and contains sentence from over 300 mobile app privacy policies. And last one is called C3PA, which is kind of specific to CCPA and include privacy policy segmentations from over 400 organizations' privacy policy. So using these 3 data sets, they actually only covered about half of the clauses we identified. So we also created our own data set to cover all the clauses we need to evaluate LLM performance. And we manually annotate privacy policy segment by ourselves and to create a ground truth data set for the rest of the clauses. So this is just show example of our prompt template. This is a snap for our prompt for a coverage task. So for example, for the system, we provide some background about, say, you have expertise in current privacy regulations, including GDPR and so on, and you have strong skill to analyzing. And for the user, so for each coverage task, we give the task description and instruction, like your task is to kind of determine whether the segment includes the information about the purpose for the business to collect or use. So this example is for clause P4, basically about the purpose to collect. And then we also test one-shot performance with zero-shot. One-shot is basically provide an example of example from the real-world privacy policy, or we do not provide an example. And we also ask the focus. For example, for this one, we ask it should focus on first-party collection, but not third-party sharing. And finally, we ask it to respond with some specific JSON format. And we also test the chain of thought, basically ask it to work out a step-by-step to be sure we have the right answer. So it will cost more time, but we want to compare the performance of using chain of thought, one-shot, and zero-shot. And this is the evaluation result of our coverage task. So this table shows the result of personal information practice and the privacy rights. So over all the tasks, we achieved high F1 score across all tasks, and at least 0.84, and mostly above 0.9, and our average F1 score is 0.94. And we also outperform prior equivalent task. So here, prior equivalent task means, so there are actually a lot of work evaluate on the OPP dataset because it has been widely used, but prior prediction task actually does not directly align with those legal clauses, so it's kind of not equivalent to our legal test. Then for the inspection task, so we actually refine the category for the inspection task from prior work, such as we add more personal information category from the current laws from CCPA and other state-level privacy laws. And we get the reasonable performance. For example, the average F1 score for first-party collection is 0.88, and our result overall outperforms existing method, and we also have border classification. So this evaluation just to show that whether we can use this LLM pipeline for larger scale measurement next. So we get to the high F1 score, then we will apply this framework to do a large scale measurement. So for our large scale measurement, we choose our target domain to use Google's top list. And we also want to compare the regional difference. So we also choose the top 1K companies' official website from Fortune list and top 500 from EU. And so I will not dive into details about our privacy policy detection process, but just this is a brief description about our detection process. So basically, we use a pre-trained machine learning model to detect those privacy policies. And I do want to mention there are some common false positive cases. For example, a website, we observed many websites embed Google's privacy policy. For example, they are using some Google service. So a Google's privacy policy is actually a privacy policy, but the privacy policy not belongs to that website. So we want our measurement result to be accurate because we want to measure a business privacy practice, and that's not Google's. So we further do SLD match to get high confidence cases. And finally, we have over 18K privacy policy documents of high confidence cases, and we manually check 100 samples, get 99% accurate. And because there are too many cases in the 100K group, so we further randomly select 2K domains from the top 100K group. So in total, our test dataset consists of about 4,800 distinct domains and 5,200 unique privacy policy documents. So I'll show the measurement result. So those heat map shows the percentage of cloud coverage of each themes. Basically, the personal information practice, explanation of privacy rights, and exercising privacy rights, and some specific disclosures. So we can see from the colors that those privacy policies, they heavily focus on personal information practice, but they have limited coverage of privacy rights related and specific disclosures. And we also find a clear trend that higher ranked domains cover more clauses in their privacy policy. So we can see a decrease of the percentage from 1K, 10K to 100K. And we expect that the higher ranked domains are more likely to fall under applicable privacy laws. And those laws require them to provide more information about users' privacy practice. And in many cases, they're also more likely to handle user data. And next, we find clause coverage can differ notably between top US and EU domains. For example, for the R10 clause, the right to non-discrimination, this is CCPA only, and we find that there is over 61% of coverage in those US domains and only 11% of coverage of those EU domains. And next is the result about the inspection task. So this table shows the percentage of like how many privacy policies disclose in their privacy policy about they collect this type of personal information, and it ranked by the first-party collection, and the table also shows the third-party sharing. And we can see the top category for collection and sharing is identifier, but it's actually a very expensive defined category. For example, identifier can include like name, address, driver's license, SSN, basically any kind of information can identify yourself. So users would not to understand concretely what the business collected their data. And next, so we add 4 new personal information category, so including the biometric, sensor, other sensitive data, and inferred data. And we also see a non-trivial percentage of those type of personal information being collected or being shared. And finally, we find for nearly all personal information classes, the majority of domains that collect such personal information also share it. So it highlights the privacy consequence of even first-party data collection. And next is about the third-party recipient of personal information. So in a privacy policy, they can either provide the specific named third-party entity or the category of third-party entity. And so we manually checked those categories and those named entities and merge them together. Finally, we list the top 10 of the named entity and the category. And this is actually a lower bound of percentage because a website, they can either provide the named entity or the category. So if one website, say Google, they send their data to Google, and another website may say they send their data to some data analytics. So that's why it shows the lower bound of data. And we can see first Google services are particularly dominant. There are 5 out of 10 named third-party recipient is Google service. And second, the category aligns with those named third-party entities. For example, we find advertising category is the top one, and we also find several advertising entities in the named entities. And finally, we find there are notable portions sharing data with governments and law enforcement. So finally, we did some case study about the specific disclosures. As I mentioned earlier, CCPA requires a privacy policy to provide a metric report on consumers' privacy requests. That report should include how many requests they received in the past calendar year about the right to know their data, right to delete, correct, opt out, and limit the use of their data. And our data set include over 300 domains provide those metric report, and among them there are 68 domains. The report was directly embedded in the privacy policy, so we can analyze the result. And first, we see that overall domains receive a limited number of requests per year. The median value range from 8 to 266 is right to correct and right to delete. And opt-out request an exception with a much higher median of like over 2,500. And they also provide the response time about each request. So we find domains are prioritizing opt-out request with 1 day average response time. And also there's no violation of the 90-day response limit required by CCPA. And there are more measurement results in the paper. If you are interested, you can check in our paper for the details. And we also open source our data set, including our privacy policy crawler, our privacy policy data set, the LLM-based framework, basically the implementation of our pipeline, and also the because we use LLM to annotate the data set, so we also released the produced annotations. And finally, to conclude our work, so we basically applying our automate pipeline at scale, and we analyze real-world privacy practice, and we get some key insight and the recommendations for stakeholders. Those stakeholders include the website or the service provider. So overall, we observe that privacy policy become longer and longer. So actually, in our data set, we find Microsoft has the longest privacy policy, include over 50K English words. And so we recommend those websites to provide a simple version of privacy policies. And we also find that those privacy policies heavily focus on personal information practice, but do not cover consumers' privacy rights very often. So we also recommend to provide broader visibility. And for consumers, so overall, we observe a limited number of privacy requests they send to those business providers. So we encourage those consumers to engage more in exercising their privacy rights. And the user education can also help them to get awareness of actionable privacy rights. And finally, for the regulators, so we validate those privacy regulations impact because we already observe some privacy policies. They disclose the specific information required by those new privacy regulations, such as Florida and Texas. And we also see some general definitions, such as the personal information identifier, and the user often cannot really understand what the business provider collect their data. So we also recommend to narrowly scope those definitions. And for researchers, the lessons is we should consider multiple different laws when we conduct privacy-related research, because we see those privacy policies, they actually contain those content required by different laws. And we also need to introduce more personal information definitions. For example, those new ones required by CCPA, and we can also consider those new technologies such as the vision and those kind of definitions. And finally, for future work, so our work focused on those English privacy policies and also focused on Western laws. So we hope their future work can further study about non-English language privacy policies and also non-Western laws. And we also hope that future work can build on our pipeline to do further privacy policy analysis. Yes, that's our work. Thank you. Yeah, and I'll take any questions.
So I guess, do you envision people like using this tool, like a website, just to check if their privacy policy is missing things, or regulators to actually, try to follow up and get more privacy policies?
Yeah,
More complete ones or something?
we actually encourage people to use our pipelines to check whether our online service they are using, whether the privacy policy of this service covers the requirements from those different privacy laws.
Mm-hmm.
Yeah.
So you're thinking about it on the user side, like the user would check, or like the website itself?
I think we will focus on more about user side, but it's actually same regulators can also use these pipelines to check like whether basically those privacy policy violate their requirements or something. Yeah.
I'm wondering, at least some time ago when I checked, it was totally fine to have this language like, oh, we share the data with our advertising partners, or some vague statement like that. Is that still okay? And is that something you're seeing?
Do you mean by
in the privacy policies?
They actually have some fake statement in
No, who knows? It's just so vague, right? It's not clear who the data is being shared with. Is that something you're still seeing?
Yes, actually, so in some description of their privacy policy, it's kind of vague, and also our system, the accuracy is not 100%. So it's kind of similar to any machine learning based system. So we try our best to detect those vague description. Yeah.
Do you think this framework could also work for other platforms other than websites, like smartphones, where there is permission models and things work a little bit different, and privacy policies sometimes are connected to those permissions or not, or sometimes they are just the same as the ones in the website, but they don't apply to the platform?
Yeah, that's a very good question. So it's actually, for that kind of work, it's kind of compare with their statement in their privacy policy with their actual behaviors, like if they really do what they declare in their privacy policy. So this is actually what we are planning for the next step of this work. So we want, because we already have this data set, and we want to compare with their actual behaviors to see if they violate their description or not.
Right. Yeah. We should talk later. I've done something similar for Amazon Alexa skills and stuff like that.
Yeah, and this is also, so we do this on the website, so can also use it for the mobile apps privacy policy, its browser extensions. Yeah.
Okay, great. Let's thank Qinge again.